Good morning, friends. I'm Suneeta Phadkule, professor in mechanical engineering, working at JSPM's Jaywantrao Sawan College of Engineering, Hadapsar, Pune. This is the lecture on the subject solid mechanics at AC Mechanical. This is our video lecture number 1. It is on unit number 5. The name of the unit number 5 is Principal Stresses and Theories of Elastic Failure. So today I am going to cover the topic theories of elastic failure. I am going to cover only theory. In the next lecture, we are going to solve few problems on theories of elastic failure. What is the learning outcome of today's lecture? So you will be able to apply suitable theory of elastic failure to predict the failure of mechanical component oblique system. Let us see. So what is the syllabus content of this unit? So principal stresses, which already you have learned this topic. Okay. So today we are going to learn theories of elastic failure. Okay. Now, what is a recap? So before starting the theories of elastic failure, it is necessary to just quickly take the review of principal stresses. Okay. So we have learned many cases for these principal stresses. Okay. So first case is element subjected to uniaxial direct stresses, okay, which is also known as the stresses on an oblique plane making angle theta. What do you mean by uniaxial? That means the stresses are acting in the unidirectional. That means this is your component and the stresses are acting only along the one direction, like tensile or compressive. Okay. So in this case, if you want to find out what are the stresses include at the inclined plane, means the cross section is not perpendicular but it is inclined. In that case, the stresses are induced in that inclined plane are known as a sigma theta and tau theta, where theta is the angle made by that plane on which we want to find out the stresses with the either horizontal axis or vertical axis. Okay. So we call it as a sigma theta or tau theta. Okay. So sigma theta is equal to sigma into cos square theta and tau theta is equal to sigma by 2 sin 2 theta. What is sigma? See, if this is a tensile stress, you have learned in unit number 1. Okay. So this is sigma. Then at an inclined plane, which is making angle theta with the vertical axis, the stresses induced are normal stress, that is sigma theta, and shear stress, that is tau theta. Okay. Similarly, second case is element subjected to biaxial direct stresses. That means stresses on an oblique plane in two mutually perpendicular direction. That means this is your element and there are two stresses. Biaxial means the stresses acting along, suppose x-axis also, and stresses acting along y-axis also. Okay. So these are the biaxial direct stresses. So if the stresses acting are the biaxial stresses, how to find out the stresses on any inclined plane which is making angle theta with vertical axis? So sigma theta is equal to sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 into cos 2 theta, and shear stress is tau theta is equal to sigma 1 minus sigma 2 by 2 into sin 2 theta. Okay. Hope you have learned already this. If not learned, we don't require this one, but I thought it is necessary to revise this portion. And the third case is element subjected to general two-dimensional stress system. General two-dimensional stress system means what? It consists of biaxial stresses also and shear stresses also. That means if this is your element, the biaxial means suppose tensile stresses are acting along the x-axis also, then normal stress tensile stresses are acting along y direction also, and there are shear also, shearing taking place along the x plane and along the y plane. Okay. So that means, see, in this case there were no shear stresses on the vertical and horizontal plane, but here the shear stresses are also acting. So what will be the stresses acting or induced along the plane which is making angle theta with vertical axis? So that is sigma theta is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau sin 2 theta. Okay. And tau theta is equal to sigma 1 minus sigma 2 by 2 into sin 2 theta minus tau cos 2 theta. Okay. What is this tau? Tau is the shear stress acting along this plane and this plane, okay? And sigma 1, sigma x and, sorry, here it should be sigma x and sigma y. It is sigma x, sigma y, sigma, this is sigma x, this is sigma y, okay? Then fourth case is, what is the formula for principal stresses? How to find out principal stresses, okay? So principal stresses means the stresses acting on that plane on which shear stress is 0. Okay, so only normal stress is acting on that plane. That normal stress is known as a principal stress. So principal stress is basically a normal stress. Okay, it will be either tensile or it will be either compressive. So principal stresses are found out by this formula. Sigma 1 and sigma 2, these are the notations we always use for principal stresses. There are two principal stresses. One is maximum, other is minimum. Okay, so both are given by sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 bracket square plus tau square. Okay, and how to find out maximum shear stress? Plus or minus square root of sigma x minus sigma y bracket square plus 4 tau square. Or you can also find out tau max by knowing sigma 1 and sigma 2. So that is equal to 1/2 sigma 1 minus sigma 2. And the last formula is tan 2 theta p. What is theta p? This is the angle made by the principal plane. Okay, so that's why we have used the notation p, theta p, principal plane angle. So that is given by 2 tau divided by sigma x minus sigma y. Okay, so this was just the revision about the principal stresses. Now let us come to the actual topic what we are going to learn today, that is theories of elastic failure. Okay, so what we are learning in unit number 1, do you remember the title of unit number 1? That is simple stresses and strains. Okay, so in simple stress system means what? See, only one kind of stress is acting in that component or induced in that component. So suppose if you take shaft, there will be only one kind of stresses induced in the shaft, that will be torsional shear stresses. Okay, no other stresses are induced in the shaft. Or if you take the example of spring, what are the stresses induced in the spring? Say only bending stresses. Okay, or you can say only torsional shear stresses. In that case, only one kind of stress is acting. So that system is known as a, or those stresses are known as a simple stress system. But what happens when we call a complex stress system? Complex stress system means in that component more than two kind of stresses, two or more than two kind of stresses are simultaneously induced. Means tensile stress is also present, and suppose shear stress is also present. Okay, so that system is known as a complex stress system. So it is very easy to anticipate the failure in simple stress system, but in complex stress system in which direct as well as shear stresses act, it is not easy to predict the failure. Okay, so engineers have been trying to predict the failure loads for various structural elements and mechanical components so that they can improve their design. Okay, so most of the structural elements and machine components, they are subjected to complex state of loading. Now see, what are the types of loading? Do you remember? Major types of loading will be, say, axial loading, maybe tensile or compressive. Okay, then bending type of load, we call it as a bending. Then torsional type of load, okay, though that is torque. And last is a fatigue. Okay, but that is a different thing. So based on these three the types of load, the stresses induced may be tensile or compressive. In axial loading, in bending, tensile and compressive both are present, but that is not called as a complex because both are of the same nature, normal stresses. And in third category, that is in torsional system, there are the torsional shear stresses induced. Okay, so when these two kinds of stresses are present in the system, that is known as a complex stress system. Okay, and now it is very difficult, very much difficult to predict the failure of such complex stress system. What type of, how will you predict the failure? How will you assume that, okay, at this type of stresses only failure is occurring, whether due to shear stress, whether due to tensile stress, or what will be the combination of that stress? Okay, So it is not easy to conduct laboratory test also, because your loading is only complex. If you remember, you might there is a say a topic you have learned, a stress strain diagram. Do you remember? Stress strain diagram means what? On this say it will be like this. Okay, so that means as stress increases, strain increases. But from where you plot this stress strain diagram? That is simply because of the simple tension test which is conducted in the laboratory. Okay, so that means you take simple component, okay, you apply the tensile load, go on increasing the load, go on increasing the load. One time will come where the component will fail. If it is a ductile material, component will be first formed, necking will be formed, and then it will be breaking. Okay, so based on this loading and what are the stresses are induced, so simple tension test, this is called as a, and from this simple tension test you can find out the properties of the material. That means what is the breaking stress, what is the yield point stress, what is the elastic stress. Okay, like this you can find out the properties of the material. But when it is a complex loading, it is not possible, or it is very difficult to apply that, to simulate that load which is a complex one, and then find out the stresses. Okay, so what procedure is followed to determine the failure or to determine the properties of such complex loading, so that you can find out at what stresses your component is going to fail. Okay, so the based to analyze now or to determine the stresses at which these components are failing due to complex loading, the scientist has suggested 5 theories of elastic failure. Okay, what is the name? Theories of elastic failure. Okay, mechanical engineer never require plastic failure. We are always working in theories elastic failure only. Okay, so there are 5 theories suggested by researchers, okay, to reach a criteria for failure, that is for homogeneous and isotropic material subjected to combined stresses. Okay, combined means whatever the types of stresses are there, more than 2 kinds of stresses are induced simultaneously in the machine component. Okay, now see, you have to assume sigma 1 and sigma 2 denote the principal stresses in any complex system. Okay, and then sigma permissible, actually here it should be permissible, I forgot to write down that notation. Sigma permissible denote tensile stress at the elastic limit in a simple tension. See, these 3 stresses always you will write down in all 5 theories of elastic. Okay, 5 theories of elastic failure. So what is sigma 1 and sigma 2? Principal stresses. What is sigma permissible means what? See, you have conducted a tensile simple tension tension test, and up to what stress the limit or the component will not fail, that stress is the permissible stress. How will you find out permissible stress? The failure stress divided by factor of safety. Now failure stress will be different for different material. Say for example, for ductile material, failure stress will be your yield point stress. For brittle material, failure stress will be considered as a say ultimate tensile strength. For fatigue loading, failure stress will be considered as an endurance limit. Okay, so the failure stress divided by factor of safety is we call it as a sigma permissible, that is permissible stress or design stress or working stress. Okay, so up to that stress we can induce, or the stresses can be induced, but if it goes beyond that, material is going to fail. Okay, so this sigma permissible is found out from the simple tension test. Okay, now see, these are the 5 theories which you are going to learn. Okay, remember how to you have to remember these theories in this sequence only. It is very easy to remember in this sequence, so that you can remember the formula also in this sequence. So what is the first theory? Maximum principal stress theory. It is also known as a Rankin's theory. Okay, because Rankin has found out this theory. So maximum principal stress theory means what? See, I told you there are 2 principal stresses. Maximum suppose sigma 1, minimum principal stress suppose sigma 2. Okay, so maximum principal stress theory. What are those theory? That statement we will see further. Okay, but here failure is supposed to occur due to maximum principal stress. That's why the name is maximum principal stress theory. The second theory is maximum shear stress theory. In this theory, it is assumed that the failure in the complex loading system occurs due to maximum shear stress. Okay, this is also known as a GEST theory. Now, these two theories are based on stresses. The third theory is based on the strain. Okay, so it is assumed that the failure in complex loading system occurs due to maximum principal strain, not stress. Okay, so the name is maximum principal strain theory. It is also known as a Saint Venant's theory. Okay, there is only one theory which is based on a strain. Then these two theories based on the strain energy. So fourth theory is maximum strain energy theory, which is also known as a Hicks theory. Maximum strain energy, you have learned in unit number might be 1 or 2 that how to find out the strain energy. Okay, so in this theory it is assumed that material is failing due to maximum strain energy. Okay, then fifth theory is maximum shear strain energy theory, or it is also known as a maximum distortion energy theory. Okay, or it is also known as a scientist name is there, von Mises theory. This theory is very much required when you work on a computer aided design. This theory is generally used there. So in this theory, it is assumed that material is going to fail due to maximum shear strain energy. Okay, so again I will tell you how to remember these the names in this sequence only for these 5 theories of elastic failure. First 2 theories are based on stresses. Okay, third theory is based on the strain, and last 2 theories are based on the strain energy. Understood? Now let us learn the first theory, that is maximum principal stress theory. It is also known as the Rankins theory. Okay, let us first read the statement, then I will explain you. According to this theory, the failure of material will occur when the maximum principal stress in the complex stress system attains, that means reaches, the value of the maximum stress at the elastic limit in the simple tension test. I am sure you might not have understood the meaning of this statement. Now, what's the meaning of this statement? See, there are 2 systems. One is simple tension, simple system, where only one type of stress is occurring. That is, we call it as a simple tension test, from which you have drawn the stress strain diagram. And there is a second system, which is a complex system. Your actual mechanical component or actual system is there, in which complex loading is there, and due to complex loading, complex stresses are induced in this system. Okay, so you have to compare these 2 systems. What is the failure of this simple tension test? You can say yield point stress or permissible, means permissible stresses you can find out from the simple tension test. Okay, and now in this complex stress system, in this theory you have assumed that whatever the stresses are induced, you found out the value of maximum principal stress, say sigma 1. So when this sigma 1 will be increasing and reaches the value of this sigma permissible, the failure is going to occur. Understood? So when the maximum principal stress in the complex stress system reaches the value of sigma permissible in the elastic limit of the simple tension test. Okay, so see here, this theory states that the maximum principal stress must not exceed the working stress for the material. That means this sigma 1 should not exceed this sigma permissible. Sigma 1 should be always less than the sigma permissible. Okay, so let us find out the maximum principal stress. You know, you have learned this formula. How to find out maximum principal stress? Say sigma 1, sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 bracket square plus tau square, where sigma x, sigma y and tau are known to you. These are the stresses induced in the mechanical component. Okay, so there are tensile stresses also, and there is a shear stress also. This is the combination of the system. That's why you can find out the principal stress. Okay, now this principal stress, okay, it should not be more than the maximum stress in the simple tension, that is sigma permissible. So in the limit, what you can write down? Sigma 1 must be less than sigma permissible. So maximum it should be equal. So sigma 1 should be equal to sigma permissible. Okay, that means if sigma permissible for suppose ductile material is 80 Newton per mm square, whatever the stresses are induced in the complex system, it should be maximum 80 Newton per mm square only. If it goes beyond that one, material is definitely going to fail. Okay, so this theory is found to give good results for the brittle material such as cast iron, glass, ceramics. Okay, so this theory usually applies to brittle material, maximum principal stress theory, because it is found to give good results for brittle material. Understood? Then go to second theory. What is the name? Maximum shear stress theory, that is Guest theory. Okay, let us read the problem, see the theory statement first. This theory states that the failure occurs when the maximum shear stress in the complex system attains or reaches the value of the maximum shear stress at the elastic limit in simple tension test. Okay, so again, what is your statement here? See, two systems are there. One is simple tension, the system on which you are conducting simple tension test, okay, and complex stress, your actual component. So in simple tension test, how to find out the permissible shear stress? Do you know? Permissible shear stress is always half of the permissible permissible stress, that is normal stress. Okay, that is sigma by 2. Sigma by 2 is the tau. And here in complex system, how to find out the maximum shear stress? You know, sigma 1 minus sigma y by 2. Okay, so when this maximum shear stress induced in the complex system reaches the value of maximum permissible shear stress in the tension test, then the failure of this complex system is occurring. Okay, so let us see how to find out the maximum value of the shear stress in complex system. Tau max is equal to sigma 1 minus sigma 2 by 2, or that is also given by sigma minus sigma y by 2 bracket square plus tau xy square. This is the under root of this one. Okay, and how to find out the direct simple, say in a direct simple stress, the maximum shear stress is given by tau permissible is equal to sigma permissible by 2. This is the always this relation is there for all material. Okay, this is approximation, but we always take that permissible shear stress is always half of the permissible normal stress. It may be yield stress. Usually we take as a yield stress divided by factor of safety, that we find out the sigma permissible. So sigma permissible by 2 will give you tau permissible. Okay, so what is your condition mathematically now? This tau max should not be greater than tau permissible. Okay, that means sigma 1 minus sigma 2 by 2, this should be less than or equal to sigma permissible by 2. Okay, in the limit it should be, this value should be less than or equal to sigma permissible by 2. Okay, that means tau max should be less than tau permissible. Okay, so in the limit you take equal sign. So sigma 1 minus sigma 2 by 2 equal to sigma permissible by 2. So 2 will be getting cancelled. So what is your final equation? Sigma 1 minus sigma 2 is equal to sigma permissible. So you know sigma permissible. So this subtraction of maximum principal stress minus minimum principal stress should be less than, or maximum should be equal to sigma permissible. Understood? Now this theory is applicable to usually ductile material. It proves very good for ductile material. Okay. Now see, this formula is good for when sigma 1 and sigma 2 are opposite. You know, maximum principal stress and minimum principal stress both may be tensile, both may be negative, or one is tensile, other is compressive. Okay, you know, tensile means positive, compressive means negative. Okay, so when one is tensile, other is compressive, this formula is good. But when both are compressive or both are tensile, in that case we take sigma 1 is equal to sigma permissible. Okay, like this. So this theory is preferred in ductile materials such as mild steel and aluminium. Understood? Now let us see the third theory, which is based on the strain. Okay, you know how to find out strain. Epsilon is equal to, or what is the basic formula? modulus of elasticity, capital E is equal to stress upon strain, that is sigma upon epsilon. So epsilon is equal to sigma upon E. So that epsilon is strain. And here we want principal strain. That means epsilon is equal to sigma 1 upon E, like that. Okay. So according to this theory, let us read the statement. According to this theory, failure in a complex system occurs when the maximum principal strain in it reaches the value of strain in uniaxial stress at elastic limit of simple tension test. That means here we are comparing strain. First you find out the strain in the simple tension test. How to find out strain in simple tension test? See, epsilon permissible is equal to sigma permissible upon E. Okay. So how to find out the strain in complex system? As there are two principal stresses, sigma 1 and sigma 2. Okay. So strain will be there due to both the stresses. So how to find out this strain? Maximum strain is equal to sigma 1 minus sigma 1 minus mu sigma 2 upon E. And when the failure will be occurring? When this epsilon maximum will be greater than epsilon permissible. Okay. Purposely I have put here permissible, because in every book you will not find the permissible word, but to understand easily or to remember easily, okay, permissible means up to that value only it is permissible. If you go beyond this value, material is going to fail. Okay. So epsilon maximum should not be greater than epsilon permissible. Okay. So in the limit, epsilon maximum should be less than or greater or equal to epsilon permissible. What is epsilon maximum? Put this value, sigma 1 minus mu sigma 2 by E is equal to, put the value of epsilon permissible, sigma permissible by E. E is going to be cancelled out. So what is remaining? Sigma 1 minus mu sigma 2 is equal to sigma permissible. So when this value will increase beyond sigma permissible, failure is going to occur in the complex system. Okay. Now this theory is considered good for materials failing with brittle fracture. However, this theory is not used in general, as it is not found to give satisfactory result in particular cases. Means in all the cases, in particular cases only it gives good result. So that's why this theory is not used commonly. Understood? Now let us go to the fourth theory. Now you know fourth and fifth theory are based on the strain energy. Okay. So maximum strain energy theory, which is also known as a Hicks theory. Now let us read the problem theory statement. According to this theory, material in a complex stress system fails when the maximum strain energy per unit volume at a point reaches the value of strain energy per unit volume at elastic limit in simple tension test. Okay. So again, here you are going to compare the two say strain energy. Strain energy in simple tension test, strain energy in a complex stress system. Okay. So let us see how to find out the strain energy in simple tension test, how to find out strain energy in complex system. So consider two principal stresses, sigma 1 and sigma 2 induced in a complex system. Okay. So strain energy in a complex system is given by, you have learned this in unit number 1 or 2, I think. Strain, how to find out the strain energy in any element? It is given by simple formula, 1/2 into stress into strain into volume. Okay. So we want per unit volume, that means per volume. So strain energy per volume is equal to 1/2 into stress into strain. Okay. Now strain energy per volume, how to find out stress and strain in complex system? There are sigma 1 also, sigma 2 also, epsilon 1 also, epsilon 2 also. That means stress strain. It is maximum stress strain, and this is minimum stress strain. Okay. So strain energy per volume is equal to 1/2 sigma 1 into epsilon 1 plus 1/2 sigma 2 into epsilon 2. Okay. Now we have to replace this epsilon 1 and write down in terms of sigma. So you have also learned in unit number 1 how to determine the maximum principal strain, okay, and minimum principal strain. So epsilon 1 is equal to 1 upon E sigma 1 minus mu sigma 2, and epsilon 2 is equal to 1 upon E sigma 2 minus mu sigma 1. Okay, E is the modulus of elasticity, sigma 1 and sigma 2 are the principal stresses, and mu is the Poisson's ratio. Okay, you know, whenever there is a perpendicular loading is there or stresses are there, if you elongate the material in the x-axis direction, along the y-axis it is going to compress. Okay, so there is a strain along x direction also, y direction also, and to consider the strain in both the direction, mu we are going to consider, that is a Poisson's ratio. Okay, so now putting the values of this epsilon 1 and epsilon 2 in this formula. Okay, so strain energy per volume is equal to 1/2 sigma 1 into epsilon 1 means what? 1 upon E sigma 1 minus mu sigma 2 plus 1/2 sigma 2 into epsilon 2, that is 1 upon E sigma 2 minus mu sigma 1. Okay, now it is equal to, you can take common 1 upon 2E, here also 2E, here also 2E, that you can take common. Then what is remaining? This sigma 1 into bracket sigma 1 minus mu sigma 2 plus this sigma 2 into bracket sigma 2 minus mu sigma 1. Okay, so it is given by 1 upon 2E. Okay, it is sigma 1 square plus sigma 2 square. Here it is minus mu sigma 1 sigma 2. Here also it is minus mu sigma 1 sigma 2, that becomes 2. Okay, so it is given by 1 upon 2E into bracket sigma 1 square plus sigma 2 square minus 2 mu sigma 1 into sigma 2. Okay, this is the strain energy in complex system. Now, how to determine strain energy in a uniaxial direct stress, that is in simple tension test? Okay, you know the formula will be same. So, strain energy per volume is equal to 1/2 stress into strain. Replace this strain, put here the value of sigma. So, epsilon is equal to sigma upon E. So, this formula you are familiar. Strain energy per volume is equal to 1/2 sigma permissible square by E. So, only this sigma I am calling it as a now sigma permissible. Okay, so equate these two, or this strain energy must be lesser than the strain energy produced in a simple tension test. So according to this theory, failure condition is in the limit this strain energy must be less than or equal to this strain energy. So 2E is going to be cancelled out. So what is remaining here? Sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 is equal to sigma permissible square. Okay, so again this theory was put forth earlier. So many investigations from their results have proved that this criteria is not predicting the failure correctly. There may be wrong prediction if you use this theory. So this is also not commonly used. Okay, now let us go to the last theory. There is a fifth theory which is based on the shear strain energy. Okay, that's why the name is maximum shear strain energy theory, or it is also known as the maximum distortion energy theory, which is also known as the scientist name is von Mises theory. This is very useful theory, and please remember this theory. You will require to use it when you will go to final year. Okay, so according to this theory, the statement is, this theory states that failure takes place when the shear strain energy in a complex system becomes equal to shear strain energy word rahila, the shear strain energy in a simple tension test. Okay, so how to find out the shear strain energy in a complex system? It is given by, see, before that one I just want to know the distortion, why it is known as a distortion energy theory. See, if you take a cube and if you try to say apply the forces in all direction, it will be crushed like this. Okay, so that is nothing but the distortion. In all direction it will be say volume will be increased or volume will be reduced. That is known as the distortion energy. Okay, that means it will make like this also. The angle between the corners will not remain you can say perpendicular. That is nothing but the distortion. Okay, so how to find out the shear strain energy in a complex system? This is the formula. How this has come now, you need not see that there is a long derivation is there. Okay, so just remember this, how to find out the shear strain energy in a complex system. So it is given by 1 upon 12g into bracket sigma 1 minus sigma 2 bracket square plus sigma 1 square plus sigma 2 square. What is g? G is the modulus of rigidity, because here it is a shear strain energy. It is not elastic strain energy. That means not E, not modulus of elasticity. It is shear strain energy. That's why in shear, whenever you consider shear, always G comes into picture. That is modulus of rigidity. So it is 1 upon 12 G into bracket sigma 1 minus sigma 2 square plus sigma 1 square plus sigma 2 square. Sigma 1 and sigma 2 are the principal stresses. Okay. So let us say open this bracket. Okay. 1 upon 12 G into bracket sigma 1 square minus 2 sigma 1 sigma 2 plus sigma 2 square plus this sigma 1 square as it is, this sigma 2 square as it is. Okay. Just wait. Okay. So after this opening the bracket, this sigma 1 square, this sigma 1 square become 2 sigma 1 square. This sigma 2 square plus sigma 2 square will become 2 sigma 2 square, and this will remain as it is. Okay. And now this you can take 2 common. So 2 divided by 12, it will become 6. So shear strain energy in complex system is given by 1 upon 6 G into bracket sigma 1 square minus sigma 1 sigma 2 plus sigma 2 square. Okay. Now how to find out the shear strain energy in a simple tension test? Again, the formula will be same. This formula only will be there, but simple tension 10 means you are applying only unidirectional load. So there will be only sigma 1, which we are calling it as a sigma permissible. Sigma 2 is 0 only. So by putting sigma to 0 and sigma 1 is equal to sigma permissible, you can find out the shear strain energy in a simple tension test. So replace sigma 1 is equal to sigma permissible, sigma 2 is equal to 0 in this formula. Okay. So shear strain energy is equal to 1 upon 12 G into bracket sigma permissible minus 0 bracket square plus sigma permissible square, and this is 0. Okay. So this will become 1 upon 12 G into sigma permissible square plus sigma permissible square. It is 2 sigma permissible square. That will be sigma permissible square divided by 6G. Okay. Now equate this with this one. That means this shear strain energy induced in a complex system must be less than or equal to permissible shear strain energy in a simple tension test. Okay. So in the limit, this should be less than or equal to this. Okay. So 6G will be cancelling out, and taking equal sign, what we are getting? Sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equal to sigma permissible square. Okay. So this theory gives good result when applied to ductile materials. Hence, this theory is used by the designers for all ductile materials. Okay. So what is the summary now? Very important step. How to remember all these formulae. See, when you write down all the formulae in a sequence, it is easy to remember. So what is the first theory? Name of the first theory? Maximum principal stress theory. Okay. So in that case, what is the equation? Sigma 1 is equal to sigma permissible. Very simple, simplest statement. Sigma 1 is equal to sigma permissible. That is maximum principal stress must be equal to sigma permissible. What is the second theory? Maximum shear stress theory. So in that maximum shear stress theory, what is the equation? Sigma 1 minus sigma 2 is equal to sigma permissible. What is the third theory? It is maximum principal strain theory, which is based on a strain. So what is the statement? Sigma 1 minus mu sigma 2 is equal to sigma permissible. What is the fourth theory? It is based on strain energy. That is maximum principal strain energy. So the statement is sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 is equal to sigma permissible square. Okay. And what is the last theory? It is based on the shear strain energy theory. So the statement is sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equal to sigma permissible square. Okay. So as you go from theories of elastic failure from first to fifth, your statement is becoming more and more lengthy or complex, you can say. Okay. So simplest statement. So now it is very easy to remember. First is only sigma 1, second is sigma 1 minus sigma 2, third is sigma 1 minus mu sigma 2, fourth is sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2, and fifth is sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. No 2 mu is there. You can remember as per your way how to remember. And on right hand side it will be sigma permissible, sigma permissible, sigma permissible. Here it is square. That's why on right hand side also it is a square. Okay. Now where do you find the application of this one? What are the mechanical component or structural element where both the more than two kinds of stresses are acting simultaneously? Say if you consider a very simple example of your bolt, nut and bolt. When we tighten the bolt, okay, what happens? The tensile stresses are induced in that bolt, but Along with that one, as there is a shearing also taking place, direct shear stresses are also induced in the bolt. So both the stresses are induced, tensile as well as direct shear stress. That's why here it is necessary to find out the principal stresses. Okay, that is sigma 1 and sigma 2. Then second example is shaft. You know the shaft is used to transmit the power. So there are many elements mounted on the shaft, maybe pulley, gear, cams, okay, so bearings. So in that case, shaft is subjected to torque also because it is rotating. So torsional shear stresses are induced in the shaft, and because of the weight of the gears and pulleys, and so that is subjected to bending also. Okay, so bending stresses are induced in the shaft as well as torsional shear stresses are also induced in the shaft. So this becomes the complex stress system. Okay. Then third example is propeller shaft of the ship, which is subjected to axial stresses as well as torsional shear stresses. Then there are many examples of pressure vessels, thick and thin cylinder, wherein combined stresses are induced, and many more examples are there. So remember, where we apply this theory or where it is necessary to use the theories of elastic failure, all the components which are failing or which are subjected to complex stress system. That means the stresses induced in the system will be of different kinds of natures. Okay, remember there are only two types of stresses, normal and shear. Okay, normal, it may be tensile or compressive, and shear, there are two types of shearing: direct shear stresses, which you are learning in bending, and torsional shear stresses, which is happening due to torque. Okay, so whenever these stresses are combined, that is known as a combined stresses. And whenever combined stresses are induced in any mechanical component, we have to use the theory of elastic failure to predict the failure of that component. Understood? Hope you have understood the theory. Now please attend my next lecture, because we are going to solve 4-5 problems on these all 5 theories of elastic failure. Okay, thank you very much.